So hello guys, you are welcome to Easy Tech Academy. You are welcome. All right, so you are welcome to mobile chip level class. So this is a lecture that is going on Easy Tech Academy channel. Okay. All right, so this is our part 2 class. Okay, whereby in our last class we uh, talk about the charging circuits. So the terms that you have to understand. So whenever you are working on mobile charging circuit. Okay. All right, so now let's do a revision on our last class. Okay, let's try to do a little revision. So I'm going to open my board. All right, so now in last class, okay, I tell you about 3 times you have to understand. Okay, that's the 3 things that I told you in that class. Okay, also VPH or V system. Okay, all right, so I told you about these 3 guys. Okay, I told you that this is a 5 volt that is coming from the charger. This is a battery. This is the voltage that is required to charge a battery, which is coming from charging IC. So it's in between 3.7 volts to 4.2 volts, and also likewise this one, which is the voltage that is going to our mobile section, PPH. All right, so I tell you into details about these 3 guys. Okay, but now I told you in the last class that I'm going to tell you 2 things that whenever you have anything that related to mobile is not charging. Okay, so you are finding 2 things. Let me say basically you are finding 2 things. Okay, all right, you are finding 2 guys. When a customer come to you and told you that as a technician that he or she mobile phone is not charging. Okay, so guys, in just a brief, you are finding 2 guys. Just have in mind that you are finding 2 guys. That's the basic of finding mobile charging faults. Okay, first you are finding if your Vbus is available. So that's the 2 guys you are finding. Basically, I repeat, basically that's the 2 guys you are finding. Okay, you have to check, does this guy is available? Does this guy come out? Okay, that's the 2 things basically you are dealing with. Okay, all right, so now I will go on schematics. We shall go on schematics, and we have to learn about that 2 guys and how to troubleshoot them. Okay, so now let me try to open my schematics. All right, okay, so all right, so guys, this is Infinix or 10. Okay, that's X68 2B. So that's what we want to use as a case study. All right, okay, so now I told you that we are dealing with 2 guys whenever you have a charging fault. Okay, so now let me tell you one thing before we proceed. All right, okay, see, this guy is another case study. Okay, all right, so this guy also, It's another case study. Okay, that's another case study. All right. But now we are dealing with these two guys. Vbus and Vbus. So that's the two guys we want to deal with now. Okay, all right. Now, whenever you have each issue on mobile is not charging, okay, the first thing you have to check is your Vbus. Let's start from Vbus. You know that this guy is the one that is coming from charge port, okay, and this guy is the one that will serve as an input. So it will serve as an input to charging IC to start work. If this guy is not present, charging IC cannot activate. Okay, the charging IC cannot activate. Charging IC need this guy Vbus to start work. Whenever Vbus reach to charging IC, just know that the charging IC will on. Now it will start a work. What is work that charging IC is do? So let me just in modern charging IC, they have a lot of work that they are doing, but let's just talk about the major work that is doing. Charging IC is like a step down IC. Let me clean this guy. It serves as a step down. You know, when we go into whenever you are talking about going to electronics basic, we have what we call step up and step down transformer. We have step up transformer, we have step down transformer. Okay, all right. So now charging IC is like a step down. It will step down this Vbus, which is 5 volts. Just have in mind that 5 volt is not a voltage that is required to charge your battery. Okay, 5 volt is a voltage that charging IC will manage and subdue to a voltage that is required to charge battery. A voltage that is required to charge battery is from 3.7 volts, generally to a mobile phone, to 4.2 volts. Any voltage greater than this, greater than this, just know that your battery will have a problem, because that's not the requirement. So if all 5 volts get to the battery to charge the battery, so that load is too much for the battery, that current is too much for the battery. Okay, all right. So having in the mind that charging IC is stepping down this guy to the requirement voltage that is able to charge battery. Okay, now that's the first cases you have to study. Okay, what are the conditions that can happen to this guy whenever you are troubleshooting charging problem? What are the conditions? Let's check the condition that can happen to this guy whenever you are troubleshooting charging problem. Okay, so the different cases that can happen. Okay, so let's go to the board. All right, so the first thing is that, you know, Vbus generally is 5 volts. There is a possibility that this guy reduce. Sometimes you can see like 2 volts. Sometimes you can see even some little current consumption on your multimeter. You just see that you just have some little number, even or not up to 5 volts. So you just see that on the test point of Vbus, this thing is appearing. So it's telling you that the voltage is not enough. Okay, all right, that's the first cases that usually happen to this guy. So this means that you have to check if that 5 volts is accurate, is complete 5 volts, which although you can have like sometimes you can have like 4.7 volts, you can have like 4.9 volts, approximately they are still 5 volts. So don't be confused. But anything less than 5 volts, just know that your mobile will not charge. And if your mobile charge, there are some cases that the mobile will charge, but now this is what will happen. It depends on the architecture of the charging cycle. There are some architecture that will not allow to charge it whenever if that voltage is not enough. So now let's say that for charging IC, instead of 5 volts, you see like 2 volts that reach charging IC. Okay, if 2 volts reach charging IC, if charging IC even step down this voltage, maybe we can have like 1 voltage. Sometimes you can have like even like little voltage that will go to your battery connector. What happens is that when it's either 1 volt or this voltage get to this battery connector, the power IC will sense that the phone is charging. That case is, you can see that your charging indicates, you have the LED indicates, the charging LED indicates, that white LED. And in that case, when you check your mobile phone bar, the charging bar, maybe your phone is at like 65%, you know that there is a logo that will be behind it that will serve that the phone is charging. You will see that logo also, but it will not increase. It will not increase. Why? Because that voltage is not enough. And where is the fault is coming from? From the Vbus, because that Vbus voltage is not enough. And there are some cases it will not even charge at all. It will not even charge. Okay, all right. So that's one case. That's the cases about this guy. And there are some times that Vbus can short. The 5 volt will be short. It will short. So if 5 volts short, if this 5 volts short, 0 voltage will go to charging IC. Phone will not charge at all. There are some cases that this 5 volt will not even appear at all. It will not even come. Okay, all right. So now let's go on schematics. Now let's try to trace. All right, so we all know that. Let me try to open the subboard. So all right, okay, so now this is our charging port. So these are 5-pin charging ports. Okay, you can see that I'm on the leg. Okay, so this is the Vbus. So the Vbus is coming from the charging port. So after then, it will get to it will pass through this diode on the subboard. Okay, through this diode it will go to this connector. So that's the 5-volt connector. You can see this ion. So that's the 5 volts where you can check 5 volts, this ion. Okay, you can see this is where the Vbus is coming from. So it's coming to this ion. All right, so that's how to track Vbus ray. Okay, that's how to track it. Okay, so now if any problem happen to this guy, so just know that you have to trace the Vbus ray from the charging port. Your charging port can cause the issue. Maybe it's not well fixed, maybe there is a corrosion on it, okay, which is not allowing the current to flow. Okay, there can be a problem with this diode, this guy. Okay, all right, there can be a problem with this guy also, this connector. That's how to track. Okay, there are sometimes if this ion remove, there's no way for that guy to be transferred, and you know that from this connector through the flex it will go to the main board. Okay, so now in order to do finishing for this guy, this subboard, just come here, check your 5 volt here. If your 5 volt is not coming, just know that this subboard have issue. Okay, the issue can come from this guy. Maybe that diode has short or has any problem, or your charging ports, this diode, or your charging ports. Okay, but this is the finishing for the subboard. Just check this connector. Now if voltage reach this connector, what is the next thing? So you have to trace your Vbus here. Okay, you have to come where is the Vbus test point? So this is the Vbus test point. This is the main board. So far when you test on this guy, if Vbus available here and is accurate 5 volts, or you have something like 4.7 volts, or you have something like 4.9 volts, so approximately is still a 5 volts. All right, so now this problem usually occurs sometimes, that you will have a little reduction like this, is because of the diode principle. You know that there is a diode on that subboard. Okay, so if voltage pass through diode sometimes, so for that diode to switch, it will conduct some little current. So that little consumption will make this voltage reduce a little bit. Okay, but yet if you approximate this, it will still give you 5 volts. So take note of that. Okay, so now if your 5 volts has reached this test point, just know that your 5 volts has get to the main board. So there's nothing concerning with the subboard or the flex. So the flex also can be the issue. Maybe the Vbus ray has been cut. Okay, all right. So after then, if your 5 volt is available here, then you are good to go. What next? Your 5 volt is going to this guy. This is Vbus capacitor, which is an input capacitor to OVP IC. If there is a problem with this capacitor, maybe this capacitor has been damaged, short, you know that your 5 volt will not get to this OVP IC. And if this 5 volt doesn't get to the OVP IC, your 5 volt will not get to the charging IC, so it will not charge. That's how to trace a charging fault. Okay, and now If there is a problem with your OVP IC, sometimes this OVP IC can short. Okay, so we have different type of OVP IC. There are some OVP IC that can be bypassed. That there are OVP IC that cannot be bypassed. Okay, so in that case you have to find another OVP IC of the same type in replacement. Okay, all right, so that's another class. Okay, we have something we call analog IC and digital IC. Analog IC can be bypassed, but digital IC cannot be bypassed. So that's another class. Okay, so let's continue. So now I have told you the work of OVP in the last class, that is a security that is mentioning the guys called Vbus. Okay, so I told you deeply on in last class that about the OVP work. So now let's continue. So after the OVP have tested the Vbus and it passed through the examination of OVP IC, then OVP IC it will release the 5 volts. Okay, it will release the 5 volts. You can see, you know that in last class I told you that when a signal is passing through different process, the name will change or have attachment. You can see that the Vbus, the Vbus OVP voltage is different from ordinary Vbus. This is what you have to understand whenever you are dealing with schematics. This is not ordinary Vbus again. It is OVP that is now giving out this Vbus. This Vbus is no longer a Vbus that is coming from your charger again. This signal is telling you that this Vbus is the one that OVP has tested and tell the IC that this guy is good. It's good for you to be used. So this guy is different from the OVP. That's why we have Vbus OVP. Okay, so I have told you in that last class that when signal is passing through some process, the name will change. Hope you get it, guys. Okay, all right. So now this is going directly to the charging IC, but not directly. There must be an input capacitor. All right, so this is the input capacitor to the charging IC, Vbus OVP. Now through this capacitor, okay, sorry, this is a coil. And notwithstanding, this is the input capacitor. Okay, so if this guy has a fault, your phone will not charge. If this guy has a fault, because that's the Vbus relay, right, it will not charge. So now whenever you are troubleshooting charging problem, so the first way to confirm your Vbus that it is present, totally present, is this input capacitor. So when you put your multimeter probe on this guy and you see that you have 5 volts, then Vbus have been confirmed and good to go. So there's no need of checking this guy, and you see that the voltage is accurate and not fluctuating. It's not going up and down. It's not fluctuating. You see that everything is perfect. It maintains the standard of 5 volts. Okay, all right. So you know that the cases on 5 volts Vbus line, Vbus relay has been solved. Okay, that's the perfect point to test. Okay, you know that this charging IC is a ball It's a ball charging IC. So you can't test the leg until you remove it. So that's the it's either you test from this guy or from this guy for the input of the Vbus to the charging IC. Okay, so guys, so now I hope you understand. So this is how to track, this is how to troubleshoot. Okay, you can see that with all this news that I am reading to you guys since maybe some minutes ago now, we are still talking about 5 volts tracking race. So when I told you that we are finding 2 guys, you will just take in your mind that it's just these 2 guys that we are now finding in charging. As you can see that there is many things that comprises on the road of a Vbus ray. Okay, that can make phone not to charge. So you see that Vbus is not ordinary Vbus. There are something comprises inside it. Okay, all right. So let's stop here guys. So we are going to track Vbus footage in the next class. So let me see your comment. So let me see your comment. And remember, if you are new to this account, remember to subscribe. Okay, and click on like button. Okay, all right. So guys, I will meet you in the next class. Bye for now.